Hi everyone. So today I'm back with another problem, and this is merge sorted array from Leet Code, and this is an easy problem. So let's get started. So in this problem, they're giving you two integer arrays, nums1 and nums2, sorted in non-decreasing order, and two integers m and n uh, represent the number of elements in nums1 and nums2 respectively. Now the goal is to merge nums1 and nums2 into a single array sorted in a non-decreasing order. So essentially what we need to do is that we are given the length of nums1, we are given the length of nums2, and we need to make sure that we are sorting it into a final um, array of all the elements from nums1 and nums2 sorted in a single big array. So let's look at an input example, and let me try to explain how can we write the code for this by looking at this first example. So given that nums1 in this case is 1 comma 2 comma 3, um, and then the remaining are 0, that means that uh, we have to somehow sort the array so that our the largest, so nums1 has already, nums1 will be the largest, um, the length of nums1 will fill up all the elements from nums2 as well. So we need to find out a way to sort this array, and nums1 is given by 1 2 3 and nums2 is given by 2 5 6. Likewise, um, this m is equal to 3, which is the length of the array, and because it's 1 2 3, they're not considering the consecutive zeros that come here, and n is equal to 3 in our case as well. So let's try to understand how we can use a pointer technique so that we are so updating our sorted array together. So into a big sorted array. So how do we do this pointer rule? So let's initialize a single pointer. So what we're going to do is that we are going to uh, yeah, so we're going to initialize a pointer here called p1, and let's initialize a pointer here as p2. What we can do is that we can create a copy of this entire nums1 array, because essentially we need to fill the nums1 array in a sorted order, because that is the largest length and it will contain elements from nums2 as well. So we'll create a copy, and so let's call this nums1 dot copy, right? uh, my bad, this has shifted everything in my code. So essentially what we're doing is that we've created a copy now, and now that we have nums1, we are going to use the pointers to iterate through our compared nums1 copy elements from nums2, and we're going to append it to our nums1 original um, in a sorted manner. So how do we do this? So if nums1, the first index, is less than the for pointer at nums2, we will be getting a 1, and then we'll be incrementing the pointer. We will moving the pointer of pointer of p1 to plus equal to 1. So this moves now. Now notice that we're going to do it recursively again. So because nums1 pointer at 1 is p1 is now at 2, and so is nums2, we're going to append from nums1 and not from nums2. Again, we're going to recursively add to the pointer, and we have reached pointer 1 at 3. Notice that nums1 at 3 is greater than nums2, so we're going to only take nums2 now element, so that's to append freeze the pointer at p1 from nums1, and now append the pointer 2 by 1. Now p1 is 3 and p1 is 5, so we're going to append this to 3. And now notice a trick here. So once we are done with all the elements of p1, we need to stop because, well, we have done with all the elements from nums1, right? There's no other elements to fill. So we need to write that in our code. And in the remaining elements from nums2 are already sorted, 5 and 6. So we're just going to append 5 and 6, and that will be our solution. So in that case, we need to kind of tweak our code a bit such that if nums1, we only take the elements of nums1 within m, because m is less than 3, so we only update the pointer until 3 and then stop and append only elements from p2 then. So I hope that was clear, and if not, feel free to leave it in the comments if you guys have any questions. But let's start writing the code for this problem. um, so what I will do is that I'll create a copy of nums1. So copy nums1 is equal to nums1 dot copy, and then let me see if this has copied. Okay, I think the copy is here. Okay, now we're going to initialize a pointer. So p1 is equal to 0, p2 is equal to 0, and p1 is the copy pointer for nums1, and then pointer for nums2. So now we're gonna start writing our code. So for I in range n plus m, because that's going to give us the entire list of elements in our to which we are appending. So for I in range n plus m, now here is where we need to do an if function. So we know that we need to make sure that in simpler words, if copy nums1 p1, right, is less than or equal to nums2 p2, we do nums1, let's call this p, nums1 p is equal to copy nums1 p1. So as I had shown earlier, if the pointer of copy nums, if the elements from nums1 at that pointer are less than or equal to elements of nums2 at that given pointer, we're going to append it to the elements of the at p1 pointer to our array, and then we're going to increment this by 1, right? Else, what is the else condition? Else, that means if it's greater, we're going to take nums1 p is equal to nums2 p2, and then plus we are going to update. So we need to make sure of two things. We need to make sure that well, firstly, our pointer p1 is less than m, right? Well, this is important because as I said in our earlier pointer, our p1 can only cross all elements from nums1 and not go forward than that. So we need to keep p1 less than m, and then we also need to make sure that our p2 is greater than n. So this is to make sure that our boundaries are not crossing essentially, and then our final will be to return nums1. Let's see if this works. Okay, accepted, and let's submit the code and see if it's running. Okay, there is an issue. If in list index out of range, list index out of range. Run code. Okay, so it needs to be greater than or equal to m, because we need to, if anything that is equivalent to n also can be broken down outside the boundary, and I think that was the issue with my prior, that was the error that was coming in this case. So yeah, I think this makes sense. So let's go through an example again with the code. Let's take the same example and try to explain what the code was running through. So same example, and let's explain it with the code that I just ran. So nums1 copy nums2. So let's look at what my code is doing. Let's also create an copy of this so it becomes easier for everyone to understand. So it's essentially a copy of nums1 that I have created in my code. So let's go through each of this. So pointer 1, which will be initialized to p1, right? And pointer 2, that is essentially initialized to nums2. And so we're iterating through this copy nums1. So for e in range n plus m, if p2 is greater or equal to n, or so if right now it's not greater than or equal to n, right? So and in this case we'll be looking at this operation, so it's false here. And or p1 is less than m, well p1 is less than m right now, m is 3 and p1 is 0, and copy of nums1 p. So our copy is less than or equal to, sorry, we're going to put our pointer not on p, we're going to put a pointer here. Yeah, and copy p1, copy of nums p1 is less than, basically, because 1 is less than 2, right? Our pointer is going to append by 1, and it's going to add this element to nums of 1, right? Now, it's going to recursively do this operation. So for the next one, it's still less than or equal, right? So this is going to append 2, and now we're moving to 3. Well, now it's now pointer 2 is less than p1, so it's going to run the else function here and append 2 to our code. So it's going to add 2 here and increment this pointer by 1. 5 is well greater than 3, and notice that what's happening here is that because 5 is greater than 3, our nums1 will, the if condition will work in this case, and it's going to move to the next pointer. But notice, and append this by 3. But notice now what's going to happen, because p1 is no longer less than m. Well, m is now m is 3 now, and we need it less than m, right? So we cannot run this operation. Now what it's going to do is it's automatically going to append all remaining elements from nums2. So that is why we have written this as p1 less than m, so that if there are any elements less than m, it will automatically increment all elements from nums2 in an sorted fashion. It's already a sorted array. So it's going to increment this to 5, likewise this to 6, and we have our final answer, return nums of 1. So in terms of time complexity, this is O n plus m, because we're appending elements from an array of length n and an array of length m. In terms of space complexity, this is O to the m, because we are adding, well, I think we're adding information from, we're combining an additional memory of m elements within our array. So I hope that made sense, and please let me know if you guys have any other questions, because that will really help me improve the way I'm explaining better as well. So thank you, and see you all next time.